Good morning. I'm Helai Huang from Central South University. Thank you very much for inviting me to this event. I think it's a very good opportunity after the COVID. We have the opportunity to chance to get together and to discuss this new topics in transportation. Mobility has been so much important now. I'm the traffic safety researcher, and I found that traffic safety now is becoming more and more important because all the people making transportation system, making a vehicle, talking about the safety, because the safety is the first priority, especially the new vehicles coming into our transportation system. So I'm going to share with you about some ideas. My presentation will first look back into the history of traffic safety research, and after that, I would like to share with you some most importantly distinct topics for the future research in traffic safety research field. So let's first look back the history of accident occurrence. Because of the vehicle relation, we have the accident, and the accident is not so easy to be avoided, to be prevented. The first, in the very early days, actually yesterday I mentioned with Professor Tony, and just now in the morning I visited the Museum of Automobile in Jeju Island. It's a very good museum. After the invention of the vehicle, the automobile, and people found that the accident is very important to protect the life of the occupant and the drivers safety. But in the very old days, they think that is bad luck. Who are more prone to be injured, to be involved in an accident. And after that, people, with the increase of the vehicle population on the road, and people want to find those occupants, those drivers who are more prone, more accident prone. And now in this stage, actually, the research focused on investigating the significant characteristics of those people, those drivers, and to blame to cause accidents. Okay, probably sometimes more intentional, and the solution just to punish the people and or re-educate them how to drive and how to be more cautious about the accident occurrence. Okay, and after that, people found that the accident occurrence is not that easy because we have the integrated system of road, vehicle, and the drivers and road users. And in this stage, actually, people found that it's very important to find a problem associated with the road and also with the vehicle, to blame. But during this stage, people think one cause for accident is postulated. Okay, each accident has one cause, one major cause, and after that, more and more accidents occur. And now people found that is a multi-causal problem. So we need to find a multi-causal approach to understand that, to solve that. At this stage, now we call it as the research stage. Okay, now more and more researchers are devoted to this field to investigate the occurrence of accidents to investigate how the road and the vehicle and the road users interacted to lead to the accident occurrence. So in this stage, the journal comes out. Okay, the first journal, Accident Analysis and Prevention, okay, was started in the 1969, the year of 1969. 2 years after the establishment of the transportation research transportation research by the same editor, Professor Frank Hay from UC Davis. And after that, more and more recently, people proposed that. I remember when I was a PhD student in Singapore, National University of Singapore, in 2004, I remember. The Sweden expert coming to Singapore to give a presentation to tell us that Sweden is working for Vision Zero. Vision Zero. I know that concept in like 2004, 2005. I don't remember. Okay, the first time I know the word Vision Zero. They say that the accident should be prevented. Okay, so at that time there is also a discussion about the term accident or crash. Okay, so many senior professors propose to use the crash. So because accident is too much accidental, okay, and the crash is just an event, okay, a collision, right? So we hope we can do our best to prevent the crash occurrence and to relieve the injury severity. Okay, so in this stage, actually more and more researchers coming into the road accident field, including the Journal of Human Factors, and after that the Journal of Safety Research, Safety Science. Okay, and after this, but in this stage, people suppose that the driver is not easy to change, but the road and the vehicle system should be more adaptive to the human limitation. Okay, about our vision, about our perception, our reaction. Okay, so the key thing is that we should design the road and vehicle system to be more adaptive to the road user limitation. Okay, to protect the people, to prevent the accident occurrence. Okay, so this is the recent stage. But actually, in China, we also have promote many programs for Vision Zero. We don't call Vision Zero. We call it intrinsic safety system. We call it. I'm not sure if there is a Chinese student over here. We call it intrinsic safety system, but we have not done so many things, and the new vehicle coming into our field. Okay, the EV, the CAV, ICV, right, many terms, autonomous vehicles. Okay, coming. So many researchers shift to do the research for the ICV, CAV research, okay, and to promote, to upgrade our system to be more collective, to be more intelligent, okay. So this is we think we are in this stage, but we're supposed to do research in this stage. So in traffic safety there is a contradiction. It's a very big challenge to handle the problem, the issue. We hope we can do more. We should put more effort on the old problems. The truck jams, the truck crashes, pollutions, but we are made more and more new issues, new challenges, like the V2I safety, okay, like the autonomous driving safety, information security, public security, and operational safety. There's so many new problems coming out. Yeah, from the more and more intelligent and connected infrastructure and weakness. Okay, and also like in China. Okay, I'm not very sure about industry development in the Western countries, also in Korea. But now in China, we have so many programs to promote the new, so-called new infrastructure for transportation. The government want to invest, and more companies want to invest, want to get money, want to develop their new production. Okay, so the emerging industry, the ICV, ICEV, and the new infrastructure are developing very fast, encouraged by the governmental agencies like the vehicular industry. In China, we call it as the Ministry of Industry and Information Ministry, and also by the development, the economic development, and Ministry of Economic Development departments. And there are so many internet companies coming into our field. Okay, like in China now, there are so many EV companies. The newest one is, I'm not sure if you know about that, Xiaomi, right? Xiaomi is now the very famous the CEO of Xiaomi, right? They just spent 3 years to make a car. Okay, I'm not sure if their car is good or not, but I know that their car are running all over the world. We need to think about their safety, right? So they push us, the traditional traffic safety people, to think about this, to do this. But our traffic demand are so slow. Now the single vehicle automation, the vehicle technology are more and more autonomous, intelligent. But our transportation infrastructure are being developed so slowly, not so easy. And the traffic demand are also changing very slowly. Okay, so we have to treat these contradictions. Okay, especially in the developing country like China. Okay, we have to meet so many people now, not only transportation people, so many people from IT field, technological field. Even we don't understand them sometimes, and they propose to the government leaders that, okay, I can solve the traffic jam problem or traffic crash problem if you buy my system. Okay, they generally say that kind of words to government. So and as the expert, as the traditional traffic safety traffic researchers, we understand, we know that it's not easy, it's not possible with some single system to solve the traffic jam, traffic crash problems. Okay, so this is the problem we have now, and also we are calling for the application of the new technologies, the big data, the big model now, and the AI technologies, the cloud computing, and the IoT, and the 5G, 6G. Yesterday, people told me that the 5.5G, okay, 5.5G is coming. Now we need to apply this into our transportation field. So this is the puzzle and challenges we have in China. I think this is more or less in some other countries. So this is what we have. We need to think about this. So before we propose the solutions or our observations, we have to look back our technological frame in this field to traffic safety. Okay, crash is very simple. Pre-crash, during crash, and post-crash. Okay, it's very simple. Pre-crash, how to prevent it. during crash, how to how to reduce the injury severity, and post crash, how to do the medical emergency, right, rescue. Okay, and traditionally we have this picture. So we have two objectives: track the crash risk and the injury severity. Okay, the two objectives. And we have four components: driver, vehicle, road environment, and the EMS. And for each of the components, we have so many elements, right? We have so many elements. And people agree that many factors, many elements interact to make the crash happen. And we propose so many solutions to change, to address the elements, and to affect the different components, and to optimize the crash risk level and the injury severity level. And the final goal is for these two objectives. Okay, and we use education, enforcement, vehicular technology, civil engineering, emergency, but the key thing is that human factor. So the human factor is the core thing in the traditional traffic safety research framework, because people drive the vehicle and the people feel the road, okay? Feel the road, and the driver make the drive, okay? Make the decision, right? So all the things linked by the driver, So the vehicle manufacturer don't need to care too much about the road design, and the road traffic engineer don't understand very well about the vehicular mechanics. So this is the problem. When I was a student in Singapore, we learned as the young scholars, at the time of young scholars, we just do investigation for the road infrastructure entities, like intersection, segment, right, ramps, all the different entities. We understand, we do the statistical analysis to understand who, where, and when the accidents are more prone to occur. Okay, so this is the traditional framework of our traffic safety research. And now there's some change. The future system wants to remove the human factor. Okay, I think there will be a very long time to totally remove, if we can. Okay. Oh, okay. So now human factor is still very important, and even now with the collective and the intelligent system, the people, the human factors are even more important. Okay, I will explain my observation. So in this field, from driver to V2X and ICVs, intelligent and collective vehicles, and focusing on the system reliability. More and more reliability. My school of transportation in Central South University is working majorly for railway system. You know, high-speed trains, high-speed railway system in China, quite successful. And my colleagues working on the truck organization for trains, they make very fixed planes, okay, to the second, okay, to the minute and second, okay, when you should arrive at some station, okay, and when you start to next station. So, but for the truck organization for road transportation, we cannot do that, right? But in the future, if we can, the vehicle can be more collected, can be more controllable, we may be more focused on the system reliability. Okay, system reliability. And but from the unpredictable to control. Okay. So all these things should put the safety as the first goal. And this framework should be changed like this, probably. Okay, with ICV here, vehicle and the drivers, and we have different aspects of safety. Okay, and now we have more and more solutions in data science, AI, and so on. Okay, so coming to the element, our framework is also changed significantly. We now have the communication element coming into our system. Communication is very important. 5G, 5.5G, 6G, right? And of course, there are so many other different modes of communication. I'm leading a big team to do the ICV technological development under the environment of the advanced communication systems in China now. It's very important. But the communication technologies are in the same time developing very rapidly. Okay, so we have to match them very well. And the infrastructure, we cannot forget to improve our infrastructure. Okay, by the Vision Zero idea. Okay, we need to make our roads to be more forgiving, right? Forgiving road, and our maintenance, our sign and marks, alignment, environment, all these things should be kept more and more safe. Okay, more and more adaptive to the drivers. Okay, and of course, vehicular engineering is more and more important. As the traffic engineer, we have to understand the vehicular technology. We have to understand how that works. Okay, especially in the electric car time. Okay, in the future. Okay, the vehicle equipment. Like 5 or 6 years ago, I intentionally made many friends from the vehicle manufacturer. I talked with them, I discussed with the problems with them, and learn from them. Okay, I have to know that what they do. Okay, so in this sense, the hardware and software are changing drastically. Okay, and there's no standard now, especially like the FSD, right, by Tesla. Okay, Tesla, the Musk visited China before 1st May. 2 days before 1st May. You know that 1st May is a quite long holiday in China. And I have had, I know this one, I cannot get sleep. Because we are doing a system, working for the vehicle to the infrastructure system. And the FSD is nothing about the infrastructure, right? So I cannot get sleep during that time. And I called all my students and my young professors in my team and to discuss about this. Okay, Musk is not doing traffic, he's not doing transportation, he's doing automation. Okay, and so these elements are changing drastically and significantly also for our system. So we have to change our research vision to especially as the traffic engineer, we have to change to the communication and the vehicular engineering. So based on the observation I just shared, I would like to, actually 2 years ago, start from 2 years ago, I had so many meetings with my PhD students to discuss what we will have in the future for safety, road safety research. What we need to do, okay, in the new era. So this is quite a brief introduction for the future studies, okay, just based on my team's observations, okay. We divide the future studies, I think, into 10 topics. 10 topics. The first group, four groups. The first one is safety infrastructure. How the safety infrastructure should be changed. The first question I think we need to answer is how dense the traffic will be. How dense? This means the density, right? The density will change because they can be collected very closely. They should be collected. They should be operated more closely to save the space, right? And they should, and how fast they should be driven. How fast? It's still like in China, 120 kilometers per hour, the limit, Paris limit? No, I don't think so. We should make the vehicle to be faster, right? So with this change, we need to change almost all the tests on the road, like the median, right? Like the guardrail. All these tests are designed with the speed limit in the before stage, right? And in current state. Okay, so the safety infrastructure should be changed, and we also need more specific infrastructure, like I called just now the new infrastructure, collected infrastructure, how to do the plan, how to do the design, and how to organize our traffic in the future. This is the first group. The second one is driving safety. We are not making vehicle, but we have to understand the vehicle making. And we should provide the scenario. What kind of scenario the vehicle needs to operate, to be operated? Okay, what is the scenario on the road? We have to provide this to them. They like Tesla, like BYD in China, okay, like the Baidu, Apollo, right? They invent the new car, and they just talked with the government to put their cars into our road network. And in this case, they are getting the data for themselves to improve their system, right? Like Tesla. But actually, who understands the best about the scenario, driving scenario, is us. We understand that very well, the best, the truck engineer. So the scenario, and of course, there are more and more new problem interactive safety. So this is the second thing. The third one is operational safety. How the traffic will operate. Okay? And so this like the real-time risk prediction, safety of leaks, the traffic flow, proactive safety intervention. And also the fourth group is ethics and law. What people know that's not easy to solve. Okay? The ethics and law related to the ethics. So I would like to share with you about these 10 topics, about my understanding. The first one is about the planning of the infrastructure. Actually, we list some topics. I suppose I told my PhD student that because there are so many graduate students here, you may choose someone as your topic of dissertation or thesis. The first thing is the macro, meso, micro, real-time safety evaluation of intelligent collective networks. Okay, how safe your network is from different aspects, different levels. Okay. The second one is multi-level infrastructure suitability evaluation for ICVs. I think why we have the expressway, because at that time, the early days, people meant the faster vehicles, with better performance to drive faster. Then we need expressway, right? We want to let them drive faster without any interaction with the pedestrians, okay, or roadside things, okay. So in the future, we need some new term, not expressway. Probably ICV way. Probably, why? Because they need some specific infrastructure. They need to be collected. And they need some roadside control to the vehicle. Probably. So we need different level of infrastructure suitability evaluation for the ICVs. Okay? And integration of multi-factors and multi-objectives in traffic safety planning. Traffic safety planning has been prevalent in the past 20 years for spatial analysis to understand the social, economic, environmental factors effect on the accident statistics and the policy effects also. But under the environment of the intelligent and collected vehicles, we need some new technology for traffic safety planning. And theories and technologies for road level connectivity and road rights allocation in ensuring the safety of ICVs. So, who collects who, and what kind of how to allocate the right of way, right? Who go fast, like the bus, right? Bus priority. Now, in the future, ICV priority or not? So this is some observations. We have done something in research on these topics, but this is far away from establishment of the framework in this field. The second thing is the design. Okay, my team has designed many systems in China for IC infrastructure. There is a very important that how we can make the system, the IC system, work, and how much we could save by optimizing the allocation of the equipments, roadside equipments. Okay, the computing, the communication, right, and the roadside ICU, right? Yeah, and of course the roadside control also. We have some fundamental research approach to do that. Yeah, but we need to focus on the new technological development in this field. Okay, for the new infrastructure. Okay, we will find that especially in China, we have many roads, many expressways. They are supposed to be well collected, but they are very expensive. That is not promoted. Okay, cannot be applied widely, right? And these are digitalization, intelligence, connectivity of traditional traffic safety facilities to meet the legal SVs. We have to change the traditional road signs to be collected, to make them collected, and to make them probably of some function of roadside control. Okay, our traffic signal, what should the traffic signal should be in the future? Okay, so this is all the questions pending for us as the traffic engineer scientist. And for smart and safe traffic organization. The road network are so big, huge network like many huge cities in China. This is Changsha. This is my city, Changsha. This is the river. Okay, it's very simple network, and how we should organize the traffic. Okay, with the collected technologies. Okay, with more and more intelligent vehicles. So implementing road ride sharing, prioritization, and adaptive allocation for and implementing self-organized cooperative strategies at intersections. Okay, in China, like in Tsinghua University, okay, professors are working on like the self-organized cooperative strategies. We propose so many ideas, and but most of the research product outcome are based on very strong assumption. Very strong assumption. That is not well matched with the real world. Okay? And achieve safety and efficiency through scientific deployment of traffic facilities, managing traffic flow, speed, direction, and vehicle type. In the HDV, human driving cars, vehicles, the people drive. Okay, how fast I should be, all right? How fast and how safe. But in the future, the organizer should have some decision making on this. The whole traffic flow should what kind of safety level we should keep for the traffic flow. Okay, with the low visibility environment, and with the heavy occupied traffic, and with some hazardous transportation coming. Okay, so all these observations should be the element into our model to let the road safety level to be controllable. It will be very complicated. So this is the first group about the safety infrastructure, the planning, design, and organization of the traffic flow. The second group is about climate safety. Wow, this is quite it's a very hot topic, very relevant topic. And actually, I also prepared about 50 slides to present here. But finally, I found that it's not easy to share with you in a very short time. Okay, my team has been working on this field for 8 years, 2016 start from 2016 for the testing scenario development. Scenario-based safety test. We have to provide the scenario to the vehicle maker, okay, or to help them to optimize their system, driving system. So establishing a sound evaluation system and testing database. The first thing is scenario database. The second one is hardware, software combined simulation on road testing and other verification force. Okay, to verify them. Actually, now so many research team announced that they have combined the hardware, software, and the whole vehicle as an integrated system for testing. Actually, as I know, most of them are not really integrated, and are not well combined or considered for the real world traffic scenarios. Okay, and the multi-level testing and evaluation system. Okay, and the safety evaluation based on scenario constructions, deliberate integration, and accelerated simulation testing. The scenario is changing with the increase of penetration rate of ICVs in the future. Okay, our environment, our traffic environment is changing gradually. Okay, so we have to make the scenario for testing updated with the system change. Okay, so many people now propose the so-called integration of testing and operation of ICVs. This means the vehicle is being driven and they are learning also. Okay, so this is quite common sense now in our field. Okay, we have to make the child to grow up gradually and learn in the during the same period. Okay. And Another thing is about interactive safety. Wow, this is a very big topic. I remember many years ago when people talk about collective vehicle. When people talk about the collective vehicle, without AI at that time, some people published in AAP, they are asking some questions about how frequent I should send the message to our label car. How frequent? And when I should send, and what kind of content I should send, and how to show it in their class, to show the message I sent. And all these questions are very difficult to answer. The human-machine interface are very important to avoid the distracted driving. Another thing is that if the vehicles are collected, what kind of the message they should share with each other? Okay. Now we are also proposing some road and vehicle interaction system. So what kind of the roadside system information should be sent in real time to the vehicle? Okay. This depends on many things, including the automation level of the vehicle. Okay. And also depends on infrastructure level. Okay, of the road, right? And of course, depends on the software capability, software computing capability. So this is the interactive safety in human, vehicle, road, and cloud systems. Okay. And so this is the driving safety. And operational safety. The real-time risk estimation and prediction. There are a large number of publications in journals like AAP many years ago, like more than 20 years ago. One major author is my PhD supervisor, Dr. Mohammed Abdati. Okay, for real-time estimation, they divide the traffic flow characteristics into two parts. The first part is before crash and after crash and after crash. And in this case, they do the investigation for how those characteristics change, okay, before and after the crash, and then to share the information with the traffic management center, the controller, okay, to prevent the crash occurrence. But now, the real-time risk estimation and prediction are totally different. Now, ICV, we need more real-time. We are not doing the statistics. We are doing the real-time decision making. We have to do real-time decision making to operate our traffic. Okay, so this is the real-time risk estimation and prediction. We have to consider the information both from the roadside, from the eco-vehicle and the other vehicles. Okay, all from the cloud systems. Okay. The second one for operational safety is the road assessment for mixed traffic flow. Okay, mix is necessary. It's necessary in the future. We mix the pedestrian and the vehicle. Okay, in all this, we do research for them, the mixed traffic. Now we have to do mixed traffic safety evaluation for what? For the mix of different level, automation level of vehicles. Okay, so this is going to be a very big topic in the future also. And the eighth one is proactive safety intervention to traffic flow. Proactive safety intervention. To be more proactive in real time, we can remove our safety belt in the future. I hope, because we can be more, we can significantly reduce our perception and reaction time. Because of the radar, because of the cameras installed and because of the high-speed computing on the vehicle and the roadside, right? The information sharing. So in this case, we need to make the safety intervention to be more proactive. So this is the dynamic land-based right-of-way allocation, variable speed limit, road sections, multi-scenario active safety control technology systems. So this is quite a topic for safety intervention. Okay. This also need to combine the road and the vehicle size. Okay. And the final group, fourth group, is about the ethics and the law. Okay. All people understand that. Okay. We have so many problems to be solved. If our vehicles are more and more intelligent and connected in the future, and if our infrastructure has been upgraded to be connected, and if the traffic organization has been well designed, okay, to be more efficient, but we still need to deal with the ethics and the law issues, right? Who to protect, who to blame, right? And we have to revise our traffic laws, right? So I also invite professors of law in our university to work with. Okay, it's very interesting, right? Very interesting, and there are so many research topics in this field also. So this is what I would like to share today with you. Just many ideas and no research outcomes. Actually, to be frank, as the editor-in-chief of Accident Analysis and Prevention, the journal, I also sometimes feel hesitant. What kind of paper we should encourage? What kind of paper we should reject? Okay. Sometimes people say that this paper is too much traditional, like from more developing countries like India, like from Brazil, from Turkey, right? They submit many papers like Iran. Okay, Iran recently submitted many papers, and India submitted many papers. They are doing the very basic traffic optimization. Okay, traffic infrastructure, evaluation of the intersection, pedestrian safety. But some reviewers will tell me that that topic is too much traditional, without big data, without neural networks, right? But some people told me that this is the safety problem in the real world. So our journal should focus on that. And you also know that there are so many new journals and also very top journals in other fields like ICV, right? ICV, ITS, ICV, IV. There's so many new journals coming to our field. As the most recognized traffic safety journal, the Accident Analysis and Prevention, how we can stand quite reasonable and rational, okay, because we think that the authors in the AAP has the best understanding about the traffic crash occurrence, about the traffic facility design, right? This is no problem. It's no problem. But now many more people are coming from internet field, coming from the vehicular field, of course, right? And IT field, they coming communication field. They submit paper to the journal, and it's very hard, really very hard to find the good reviewers also, But we recognize that we should be more open to them, because the future system will be very open to them, right? They are in, okay? So as the traffic engineer, we should be more open and be more active to embrace the new technologies, and especially for traffic safety research. We have so many good opportunities, so many good topics as I mentioned in this presentation. this is just a very little part. We just want to make like a framework, right? To you, some hint to you. I'm also not sure where to go in the future. Where to go in the future? What are my research now? My team is to create the real world accidents into scenario to test them. Okay, I told my student that we should be the judge first because they come into our road, right? So we should be the judge, and after that probably we could help train the system. Okay, help the training of the systems and the vehicles. So and it's hard for us to make the vehicles. Okay, but we can be a very good judge because we understand our road scenario very well. Okay, so this is what I would like to share with you in this morning presentation. I would like to thank again for the opportunity to share with you. To be frank, I've been in China for 14 years. Okay, back from Florida. I have so many, I think, good observations. Actually, most of them are in the background of China environment. Okay, we have so many programs. So this is what I have in this presentation. Thank you. Thank you again. So we need a Q&A.
Yes,
right?
yes.
Okay.
Thank you for sharing the great insight and the possibility of the research in traffic safety, Professor Huang. So probably having many questions from the floor. So please raise your hand if you have a question.
I'm not sure if the students are graduate students or
Yes, graduate students
Yeah,
and
graduate
PhDs.
Yes, lady first.
Thank you for your presentation, Professor Wang. I'm also very interested in the ethical problems. May I ask how to validate and quantify the result of ethical trajectory planning for
What ICV?
Yeah, ethical.
Ethics.
Yeah,
Okay.
ethics.
Okay.
How to quantify ethics trajectory planning algorithm for the vehicle? How to validate?
I have no idea. I'm not an expert in this. I just know this is an issue. How to quantify the ethical?
Yeah, if you develop such
Or if you
planning algorithm.
Anybody else or professors have an answer to the girl? Please.
I don't have an answer, but I read a science paper, or maybe a nature paper about 4 or 5 years ago. And then what they did, it's an MIT team.
Yeah.
And what they did was they create an online game. So in that game, you can create different scenarios. Like, for instance, on the left, there are 2 young kids. And on the right, there are 5 senior people. And then if you are running a car, you have to pick the left or right. And then what you are going to pick. So they allow people to create this type of scenario, and then they collect data from the entire world. I think they collected maybe thousands of scenarios from Asia, from Europe, from all the other countries. And so in that sense, you can kind of quantify how people value the ethics in a way, or how they value like human life, like senior, younger people. So after they gather all the information, they run a regression model and then they come to that. So I think that might be one way that you can consider.
Yeah, if there is such a planning algorithm, for example, on this figure, I want to ask how to quantify such algorithm.
Helai, if I may add something.
Please. A good answer.
The thing is, when they do this kind of experiments, they understand humans' preferences of what should be done, what we call ethical, but that is barely translatable to what the cars in actual real world are going to do. Because the thing is that an automated car is not going to be working based on an what-if algorithm scenario. It's a neural network situation. It learns something and it applies, right? And how these kind of what-if scenarios, these are all what-if scenarios, how they can be taught to the machine so that they apply it based on that principle in the case of an unavoidable harm. It is very difficult. That is why this stuff has never seen the light of the day beyond the papers in Nature and Science. They always stay in Nature and Science. It's very difficult to translate them into neural network algorithms that strictly stick to these guidelines, because the guidelines are what if, whereas neural network is not what if.
Thank you. Good answer.
It's like a discussion.
More questions?
It's like a discussion session. That's good. Okay, anybody? Yeah, you first.
Yeah, hi, Prof. I really appreciate you talk about the research trade and the emerging technologies in their applications in transportation field, especially in safety. I'm actually wondering, how's your opinion about large language model, their application in transport? Large language model, like the ChatGPT we're using every day.
Okay.
So their applications in traffic safety specifically.
Yeah, I got a young professor in my team. My PhD student was visiting. Dr. Han Zhou, okay, just get first prize in the national competition with a team of undergraduates in China, okay, with the large-scale model. To do what? To do the accent narrative recognition, and from the words to image to video. Okay. Actually, we work with the Ministry of Public Security in China, the traffic police department in China. I think that they announced that they could be applied in three directions. The first one is to revise, to improve the quality of the accident report. Okay, to read the report and fill up the variables, automatic, text manual. That's okay. Second thing is that for the roadside hazard recognition. Okay, the hotspot identification of the road safety. Because my team has done so many projects on finding the hazardous road site, okay, for local government, and we have a vehicle drive. Originally, we just use the vehicle, the driver to observe, okay, the driver to observe the roadside hazard, and now they are trying to apply the large-scale model to transfer the image to the problem automatically, and also the countermeasures. And of course, now they are doing they use the image video to transfer to automatically transfer to be the testing scenario for autonomous drivers. This is what my team is doing. Okay. As for the broad application in the future for vehicular technologies, I think it's not preventable. It's not. This is on the way, on the road to the future, I think. And we generally want to some analytic. Actually, our road safety analysts prone to more statistical, to analytical approach, because we hope to understand what happens in the field, inside, right? So what kind of the signal lead the occurrence of the accident, okay? So for quite a long time, my PhD dissertation was crash prediction model using the hierarchical and Bayesian approach models. Okay, we would like to we divide the data and the problems into different levels, the regional level, the roadside level, and the crash level, the side level, crash level, and the weak level, okay, into different levels. But in the future, we cannot prevent the application of the black box, the so-called black box, right, algorithms, because they are more efficient. They are more, they have better capability to learn. So I encourage my students to work in this field. But in the future, I think this is not only for the vehicle. I think this is for the whole life, the human life, right? In the future with the large scale model, right? So this is what I can answer you. Thank you.
Okay, let's go ahead.
Hello, I'm PhD student Helai, and thank you for your good presentation. And I agree that it is necessary to study traffic safety in mixed traffic between ICVs and human driving vehicles. Although the introduction of ICVs will increase road safety, but some researchers say that it makes negative impact because of the conservative behavior of ICVs. So how do we consider the trade-off between road safety and road operation or driver efficiency? So I want to listen.
You mean the safety and the efficiency, right?
Yes.
Yeah, the trade-off. Yeah, thank you. I mentioned, I remember in my slides about the safety and about the traffic organization. The safety and efficiency, right? So this is a real question of, I think it's a permanent question. To save one life or save 1,000 hours. Yeah, I generally ask my students in class, what do you choose? To save a life or 10,000 hours, right? So in the United States, in Singapore, in Europe, in Japan, I know, I'm not sure in Korea, they invest the infrastructure, upgrading money, okay, by estimate how many lives we could save. Okay, in the United States, in the HSN, I remember it's like $4 million, right, per night. $4 million.
$4.5 million.
Right.
I think it's $4.5 million.
Yeah.
And
It's very expensive, right? So this is, and in Singapore, you know, I was in Singapore. My junior Professor Shimu calculated that 2 million Singapore dollars per night. So it's cheaper, right? The Singaporean and the China people, we don't count it because we just count the direct damage, direct loss of the accident. But in the future, we do need some algorithm, something to balance the safety and the efficiency. This depends on what safety level we should control. I think what we should do in the future, the safety level should be the threshold, and then to increase the efficiency. I'll give you an example. Now, just now I mentioned I'm the PI of a big project in China to making the ICV. There is a requirement. They ask the TTC to be less than 3 seconds. TTC, time to collision, to be less than 3 seconds. Actually, I don't understand originally how why we should keep the TDC to be less, right? Because after that, I understand that they ask the traffic to be more dense, right? The cars should be followed more dense, right? So the TDC 3 seconds is a threshold, is a baseline, right? To increase the efficiency of the traffic flow. So in different scenarios, we need different research, yeah, in the future. So I think this is a very good direction in the future. Okay. Thank you.
Okay, one last question. Okay.
Good. Chinese students don't raise hands.
Professor, thank you so much for the presentation. And I'm a PhD student who right now research interest is about the pedestrian safety at intersection. So I'm aiming to establish a real-time warning system. So my question is, I saw you mention about there is a need for the proactive risk predictions. So my question is, what do you think the different safety evaluation metric it should be for the proactive system and for the post system? For example, for the post system, we have the traditional surrogate safety measurement. And for the proactive system, what should this kind of evaluation metric, the characteristic they need to achieve? For example, they need to achieve real time, they need to achieve robustness. Which characteristic do you think is more important?
Okay, thank you. It's a very big question, actually. Sit down, please. 500 ms. 500 ms is a threshold for reaction of a vehicle. And now we require about 100 ms/s, 100 for emergency to the vehicle. So how fast the vehicle should be responding, the threshold. And for the general event, we ask for 200 or 300 ms/s. Okay. This is for vehicle. For vehicle, we need some specific threshold. You know that our human driver is like 1 second, right? 1 second perception and reaction time. 1.2 or some good people, better people like 0.8 seconds. So we ask the vehicle to be more respondent. Okay. And for the, like you mentioned about the pedestrian and the vehicle, the crash risk and intersection, I'm not sure in the future how the pedestrian could be organized. I don't know the organization. In the future, some specific lane for pedestrian or flyers, or I don't know. It depends on how collected and intelligent and how fast the vehicle should be, and what kind of the vehicular organization should be at the intersections. Then we may decide how pedestrian could cross the street, right? So all these things, and also we have people propose the so-called eHMI, right? External HMI, human-machine interface. They install something on the top of the vehicle to tell the pedestrian something, and also people also propose to put something like watch, right, into with the pedestrian, and they can collect it P to V, right, V to P. So there's no common sense, I think. Currently, there's no common sense. Yeah, but this is also very difficult to answer. Very difficult to answer. Okay, I know the vehicle. Like I said, I think our focus in our project is 100 ms/s. Yeah.
No answer.
So many good questions.
Oh yeah.
But unfortunately, I cannot answer most of the questions because it's long.
Well, so many great questions and answers.
Okay.
So maybe one last. If you really want to do this, then okay, let's go to just
One more, okay, please.
Morning, Professor, and thank you for your presentation.
Please speak louder.
My English is not good,
My name is
so
Paolo.
you have to speak a lot.
Okay. My name is Paolo, and I'm from the Philippines.
Yeah,
And
Philippines.
I was just interested in what you said about publishing papers from developing countries, because you mentioned that some of them are still in the traditional topics, and there's a dilemma on publishing them or accepting the things that are already novel and new and keeping up with the technology. So my question is, how do you think should researchers from developing countries focus in moving forward and keeping up with the technologies existing already, so that they could also create more impact? Because I think that this is a good opportunity for these countries to leap to the technologies that are already existing. But I think the problem would be the resources and investment in infrastructures. So how do you think should be the way forward so that
Okay.
researchers can start?
Okay, I understand your question. It's really, I remember 20 years ago, the Chinese universities joined very actively joined the TRB, right? At that time, actually, Chinese people has no very well international collaboration, right? And we invited the the professors from Europe and the US, Japan, Korea, to China. At that time, our infrastructure are quite low level, right? And in the past 20 years, we have experienced fast, rapid development of our infrastructure system in transportation. I understand you very well. I understand the Iran people very well, and the Indian people very well. I know the problem because you have no opportunity to get big data, and there is no big investment into the new infrastructure, right? But you as a researcher or the engineer, you are trying to solve the problem, okay? But as a researcher, you want to publish, you want to produce good research outcome. I understand this very well. So as the role of the editor of AAP, I'm trying to keep the balance. Okay, keep the balance. But the key thing is that you should not repeat. You should make your specific case to describe it. Don't tell me that, okay, I applied elective binomial models into Philippine crash frequency estimation. This is innovation the first time in Philippines. No. Because I used that 20 years ago. Right? So you must tell me that I developed a model specifically to Philippines. And this model is very useful. And we can share some ideas with other countries. Okay? Not only the technology. Okay? I just mentioned that in 2003, my PhD dissertation is based in hierarchical modeling, okay, and spatial modeling, like the random parameter now very prevalent in the MAR, right? Yeah, we have developed the technologies, the analytics to be very far, right, far away from the application actually, right? The HSM, Highway Safety Manual, is a very good Bible, I think, to be learned from developing countries. Yeah, okay? So that's my answer. Don't worry about that, okay? If you submit papers, I will judge if you have innovation, okay? The innovation is not only for innovation to the Philippines. You have something to share with other countries. Okay, thank you.
Okay, well, thank you. Yeah, thank you.